interesting analogy. Okay. Okay. Yes. This is number 7 from, I think, version A, but you guys have this as well.
It's 11.
11 on B, on version B. And on version B, what is your number? Y equals x to the 3x? Oh, you have the exact same thing. That was really original. Okay. I just moved the things around. Okay. So, use logarithmic differentiation. So, there's a specific order you must go through. And the reason I'm going through, because I know different places that we made mistakes. So I want to make sure stress. First, logarithmic differentiation, you take ln of both sides. Okay, so ln of both sides. For the most part, yeah, you guys all did this part, which is solid. So ln of both sides. Then you can use power rule property of logarithms. I don't know. Is that the exact name? Whatever. Logarithmic property of exponents, where if you have ln of something to a power, you move the power in front. Okay. So I have ln of y equals 2x times ln of x. Okay. Now, it is at this point that we can differentiate. So the big ol' operator, right, our verb d dx, this means differentiate. It means take a derivative. So on the left side, the derivative of ln of y, okay, derivative ln, 1 over whatever inside. And then, since we're trying to take the derivative with respect to x, we know there has to be a derivative associated with y. Or you can just think, whenever you're doing implicit differentiation or logarithmic differentiation, if you run into a y, you have to tack on a y prime or dy dx, your choice. Which one do you want to go with? What? Spencer, y prime or dy dx? dy dx, okay, cool. Nope, he said dy dx. Cool, because it means the same thing, right? Dy dx means y prime. Okay, and let's go on the left side. Ooh, guess what this is? 2x times ln x. 2 functions being multiplied is a product rule. So I'll have u be 2x, which means the derivative is 2. V is ln of x, and v prime is 1 over x. Okay, so interesting thing with logarithmic differentiation is this is always one of your products. Because it's always one of them is always ln of x. For at least the ones I'm going to give you. There's a lot harder examples we could do with logarithmic differentiation, but I just stuck with x to some power of x. Because then I just want to know you can do the method. Okay, so power rule. I have u times v prime plus v times u prime. And notice when I have 2x times 1 over x, that goes away. So to get dy dx by itself, aka let's find that derivative, I'm going to multiply both sides by y. Alright, multiply both sides by y. That way it cancels out. Multiply this whole side by y. And then, we have to go back up, see what y was, and then put it back down here. So I might have done this problem for you on your paper. I'll talk about common mistakes in a moment. Let's finish this. Dy dx equals 2 plus 2 ln x. And then the y is x to the 2x. Okay, and that is our answer. It's like 5 steps. First, ln both sides. Then, move the exponent to the front. Then we must differentiate. Right, on the left side, it's a little easier because it's 1 over y times y prime pretty much always for the problems I will give you. In college, you'll have some harder ones. And then on the right side, you have a product. So this is the first place where people start going wrong, is they may have left this all the way down, so we have 2x times ln x. Another thing people did was like, oh, I see ln x, so I say 2x times 1 over x. Like, no, we're doing product rule, and this takes care of the derivative of these two things being multiplied. Don't just randomly differentiate things in the middle of a problem. Like, follow the rule. This is what I mean when I say follow the rule. Product rule tells you exactly how to find the derivative. So you can't just randomly turn ln x into 1 over x. Right? So using this rule, I don't know another way to say it, just follow the rule. ln of x is not the same thing as 1 over x. The derivative, right, the slope of the equation ln of x is 1 over x. Okay, other questions about this one? I think it makes more sense.
Can we do the find the slope of the tangent line? We have to like understand what like cosine is.
So fun fact, we're going to do all the problems.
Oh, okay.
Yeah.
Sorry.
It's fine. I just said make sure you understood that. Okay, use implicit differentiation. Find the following in the following function. Okay, we want to find dy dx, aka first derivative, and this is my function. So dy dx, the thing on the bottom is always what you want it in terms of. So we are only working with x and y in this class, but in actual fun, it's real fun fact, when you do harder calculus, you can have it in terms of other variables. You can have multivariable calculus. Aha! Okay, whatever. So it's not.
There's an x and a y.
I mean, it's all like in terms of one thing, though. Everything's in terms of x. We're taking the derivative in terms of x here, which is why whenever we hit a y, we have to do a y prime. Yeah.
Guess I'm not gonna pass that.
No, you can. You can do it. I hope you come back in like 5 years and you're like, I understand, Ms. Soper. Like, yes. That'd be great. Okay, so I'm just going to rewrite this problem. So it's down here. Okay, now I must, remember the chop suey guy? Choo, choo, right? D dx. Literally, hit it with taking derivative. We're trying to take the derivative. Okay, I don't know if that made sense. If you never look at the topics tab, that would make no sense.
I got it.
I know, but I don't assume people remember that. Because my other classes don't. Okay.
I remember everything.
D dx. Okay, ready? Derivative of y. 1 multiplied by y prime. Okay, so it's just y prime. Whenever you hit a y, and you're taking the derivative with respect to x, you just hit that with the y prime. And then we have to use chain rule. What's the derivative of sine? Cosine. And then take the derivative of the function inside, derivative of y prime. So some people forgot to actually take the derivative of sine of y, and they left a sine of y. Some people forgot to include, tack on the y prime, which changed your answer. And then this is a tricky one, derivative of x. 1, yeah. Sometimes we left it as x, sometimes we put 0. You just bring the exponent down, subtract 1 from the exponent. 1 times x is 0 is just 1. Or you just think, derivative of x, 1. Derivative of 2x. 2. Okay, cool. So we're good. All right. So we're trying to find dy dx, which is literally the same thing as y prime. So I'd like to factor it out since it's a common factor. And then divide both sides by 1 plus cosine y. Okay, well, hopefully it makes sense now, yeah? Okay. Okay, and then the next question depends on this answer. So, right, I'm, not to toot my own horn, but I was very nice. There's a thing called carry through error. If you at least plugged in to what you found in this problem, and you like did your computation right, I wrote carry through error and give you the points, because then at least you understand slope is the derivative you just found, and if I want it at 0, 0, plug in 0 for x, 0 for y. So here, if I want the derivative at 0, I have 1 over 1 plus cosine of 0.
Okay, can we do a little mini lesson of like cosine of like that, like cosine of 0, sine of 0, because I don't understand.
I was about to explain what cosine 0 is.
What?
I was about to explain what cosine 0 is, yeah. So one thing we missed, cosine of 0, it's either 1 or 0, right? Those are the two answers I got. So think about it. Cosine of 0 degrees. 0 degrees is right here. This is 90 degrees, 0 degrees, 180, 270, and cosine is always your x value. What is the x value right here?
1.
Right, so our coordinate is 1, 0, cosine would be 1. So I have 1 over 1 plus 1, which is 1/2. There's like, I don't know, 2 people where it's really weird. You put like 1/2 down here, and then you put undefined up. Okay, volunteer. This is why you show work. If you didn't show work and you just wrote undefined, no points. Maybe I'll give you half for pity. Yeah.
But we're trying to find cosine of 0.
We did. Cosine of 0 is equal to 1, and that's what I put right here. Because cosine is your x value at 0 degrees, and that's the coordinate I wrote right here. Tall?
So you're trying, but cosine is the x value. So
yes. And the x value right here is 1.
X value is 0?
No, we're trying to evaluate cosine at 0 degrees. So at 0 degrees, what is my x value? Okay.
What are the problems again when you have like the restrictions?
So if you're doing inverse,
Can you let me get there?
I think is there a problem here? If not,
Can you just remind us of the restrictions?
So my goal is to like go through like the harder problems and somewhere on the final. So if there's not one that we run into on this test, hoping to have enough time that we can go to your review and like hit some of those. This takes 2 seconds. Let's do it. Whatever. So restrictions, like sine inverse restriction, if you're trying to evaluate. So if you have, it's kind of like when you are given a square root versus you're taking a square root, right? So if I give you sine inverse of 1/2, there's only going to be one answer, versus if I say, I know this is dumb, but this is the way it is. If I say sine of theta equals 1/2, and then you're taking the inverse, there's 2 solutions, versus if I give you the inverse on the paper and you're evaluating, there's 1. Weird. There's like these little subtle things in math that drive me nuts, and this is one of them. All right, this is equivalent to like something like taking the square root of 9 versus x squared equals 9. Right? To solve the bottom one, you have to take the square root, and that's when you include plus or minus. So if I'm giving you sine of theta equals 1/2, there's technically 2 solutions where this is true. But if I give you the radical to evaluate, you only say the positive one. If I give you the inverse to evaluate, you have to restrict your domain. You have to restrict it between negative pi over 2 and pi over 2. Maybe does that make a little more sense? Or you want to know what the restrictions are?
Yeah.
Okay, for sine inverse, for sine inverse and tangent inverse, they're negative pi over 2 to pi over 2.
All students do calculus, there's nothing else.
No, that tells you where it's positive and negative.
Oh.
So if you like think about it, we want to restrict it, so we have one quadrant where sine's positive, one where it's negative. Sine is positive here, sine is negative here. We need, for tan inverse, we want to include one quadrant where it's positive, one quadrant where it's negative. But if I try to have this as the restriction for cosine, cosine's positive in both of these. That's why cosine's restriction is 0 to pi.
Wait, would you say pi over 2 to negative pi over 2?
No, negative pi over 2 to pi over 2. Negative pi over 2 to pi over 2 is sine inverse and tan inverse. But cosine is 0 to pi for cosine inverse. Okay, so what is sine inverse of 1/2? Well, first, that's positive, right? Sine is positive, so it will be in the first quadrant. Huh? Yeah, so the answer to this one would be pi over 6. But if I'm looking for sine of theta equals 1/2, there's 2 solutions to this. It could be pi over 6 and 5 pi over 6.
That would be in the fourth quadrant.
This one is in the second quadrant where sine is positive. Solving versus giving you the inverse.
Okay, so when
Right, so solving for
solve,
x
there's no
solution.
restrictions.
Yeah, versus if I give it to you.
Yeah, okay.
Yeah.
Yeah.
It's similar to the root. I don't know, it's the way my brain works. Okay. Next one. This is straight from the quiz from 3.6, 3.7. I believe maybe on the quiz I put like equals 9 or something. Equals a constant number where the constant number's derivative is 0. Cool. So first, we want to find the second derivative. Before we do that, we have to find the first. So, oh my gosh, it says implicit differentiation, which means when I hit a y, Gotta tack on dy dx. So let's go ahead and let's take the derivative. X squared minus y squared equals 4. Derivative of 2x, I'm sorry, oh God, x squared, 2x. Derivative of negative y squared, negative 2y, but then I must multiply by, yep, okay, let's do dy dx here. Think on your answers if you got it wrong, and I showed you how to do it, I just put y prime. It's 3 less letters to write. That's why I did it. Okay, and derivative of 4, 0. Okay, you have to follow order of operations to get the derivative dy dx by itself. So, subtract 2x on both sides. So I have negative 2y times dy dx equals negative 2x. Then you must divide by negative 2y. The negative 2's cancel out, and I'm left with dy. dx is x over y. So this is the first derivative. So you should have gotten, depending on like the rest of your problem, if this is all you did, I think at most I gave you 2 points. But if you like saw, if you continue down the road of second derivative somewhat properly, you could have sprinkled in a couple, maybe one more. Okay, if this is the first derivative, we now have to find the second. Meaning, I want to take the derivative of the left and right sides. So derivative, when you take the derivative of dy dx, it just turns into d squared y over dx squared. All it says is, hey, now this is the second derivative. X over y is, what should we use? Quotient rule. Quotient rule. I want you to try it. We went over quotient rule yesterday. We need to make sure we do it correct. Let's do it. Take it. Quotient rule.
I have a question. So I figured I'm finding the derivative, so then I use the quotient rule, right?
Yes, except you have a plus. It's
Yeah.
minus, not plus, because it's take.
Yeah, I understand that part, but why is still the
Because you have to take its let's see, low d high, take high, derivative of this low one is dy dx. Derivative of y is y prime, dy dx.
Okay, thank you.
Yeah. Low d high, take high d low. Derivative of y is dy dx. Cross the line, square the low. Wonderful. And then there's like a 1.5 worth of like simplifying. Yep. So I have y minus x times x over y squared. So I want to simplify this. The top, I have fractions, so I should make it have a common denominator. So I multiply the y by y over y, because technically that's multiplying by 1, and anything times 1 is itself, right? Okay, so now I have y squared minus x squared over y all over y squared. So I'm going to write the answer first, then I'll describe how I got it, if we're confused. So think about if I have y squared minus x squared over y, instead of dividing by y squared, I can multiply by the reciprocal of 1 over y squared. Right? Instead of dividing by y squared, we can multiply by the reciprocal of 1 over y squared. Cool. Make sure we understand where that cube came from. So you'll notice, I don't know, I thought it was a lot more tricky to find the second derivative. So that's why I put more partial credit there. Because there's a lot of places you can mess up. Okay. Questions about this one? Look over your quiz. You'll recognize it. All right, this one. Oh, man. Chain rule. Chain rule. One more time, chain rule. Whenever, like, this is probably the top thing we messed up on. Like, a trig function to some power of a function inside. Like understanding that this 4 means that this is literally cosine of x, all of that being squared. This is what we struggle with the most. You have to deal with the exponent before you deal with what's inside, right? For chain rule, you got to work your way from the outside in. So if you don't understand what I just wrote in pink, spinal is going to be rough because it's chain rule. You have to understand when you have something like cosine squared x, which we went over multiple times in pre-cal. We said this is the same thing as cosine squared. And then, oh my gosh, there's an exponent on the outside. So you got to deal with that first. And then you go inside, can deal with the trig function. I don't know another way to say this. Uh-huh.
Might be a really dumb question.
Nope, let's just go.
But, you know, always that tangent x is secant squared?
Yes.
So, like, if you guys like tangent squared, would it be secant?
No, because you have to use, so tan squared of x, tan squared, you write this as tan of x squared. So we did have a tangent squared problem.
Have like 2 tan x times secant squared.
We had a tan squared problem right here. Where rewrite, whenever, you know what, just make this a rule for yourself. Whenever you see trig function to some power, rewrite it so that way the parentheses are on the outside with the exponent. So this is the way, like, is why I always rewrote it in class, is so you can see this whole thing is to an exponent. Yeah. Because cosine to the 4th power's derivative is not sine to the 4th, negative sine to the 4th. We have to use chain rule. So y prime is going to be 4 times cosine of x to the 3rd power. So I dealt with the exponent on the outside. Now I have to go inside. Derivative of cosine of x. So that's negative sine x. So the derivative is negative 4 cosine cubed x times sine of x. Now that I have that, I have the equation for the slope, I can find the slope by plugging in pi over 4. Negative 4, let's see, times cosine pi over 4 cubed times sine of pi over 4. Oh my gosh, I've never... Okay, so this is the same thing as negative 4 times root 2 over 2 cubed times root 2 over 2. So this is negative 4 times 4 over 16, so that's just negative 1. The biggest thing people miss with this problem is not using chain rule. For the most part, we know derivative of cosine is negative sine. Just like, you have to use chain rule. We didn't learn derivative of cosine to the 4th. We learned derivative of cosine. Okay. Yes?
It's more real quick.
Yeah. Okay, let's keep going. Trucking along. Okay, hopefully you're like trying these problems, writing them down. Like, let's not be bobbleheads today. Today is not the day to be a bobblehead. Like, if you don't understand it, you just gotta like ask it, okay? Yes, Hannah.
I don't understand how you find the cube. You do root 2 over 2 cubed. How do you
So,
do that step?
2 root 2 over 2 times 2 times 2. But wait, this one right here gives me another root 2 over 2. So, this, right, when you root 2 times root 2 is just 2. This is just 2. And then 2 to the 4th. 2 times 2 is 4. Times 2 is 8. So this is 4 over 16. Because if you have root 2 times root 2, this is the same thing as root 2 squared. And square root cancel out. No.
So when you have the cubed or the square, you have to square the top and the bottom.
Yep. Okay. Cool. Cool. Leave this. Can you leave this up? I'm screencasting. You always can go back to the YouTube video and just like pause so you can see my writing. Okay. The particle moves along a line. You know, we did very well on this page. I just want to, like, we can briefly touch over it. We did very well on this page, though. These were the 24 points that helped you. Yep. The only thing people miss is like maybe the first one. A couple people got some points off just because computation errors. 8 minus 2 is 6, not 4.
No, 8 minus
Negative t,
Whatever it is, I forget what the exact one was. The 2 people that missed it had like the same problem. It's like, okay. A particle moves along a line, so its position at any time t is greater than or equal to 0. It's given by s of t equals t cubed minus 1.5t squared, t squared. Where s is measured in meters, t is in seconds. Average velocity. So average velocity is literally the slope equation. So you take s of, in the first 2 seconds, 2 minus s of 0. Oh, so I think the B version is like from 4 to 2 seconds. Is that wrong?
No, it's also first 2, but they're different problems.
Ah,
It's t cubed minus 0.5 t squared.
okay. I can do that one next if you want. Okay, so minus 2 minus 0. Okay, so let's find what s of 2 is first. S of 2 is, let's see, 2 cubed minus 1.5, 2 squared. So that's 8. 2 squared is 4. 4 times 1.5. Well, 1 times 4 is 4. Half of 4 is 2, so add it, it's 6. So 8 minus 6, which is 2. S of 0 is 0. Because all of these have t's in them, so 0. So if I actually plug in the numbers, I get 2 minus 0 over 2 minus 0, so you just get 1. Wow, that one was really easy. Okay, and if I do it for the other group, this is your equation. So it's from 2 to 0, but here, s of 2 is equal to, let's see, 8 minus 1/2, let's see, 2 squared is 4, so 8 minus 2 is 6. 6 over 2 is 3. Because s of 0, once again, for this one is 0. Okay, find instantaneous velocity at time t. I'll use maybe pink for this version, green for the other one. How's that? Let's go through and do the first, pink, yeah. Let me rewrite this in green, maybe you can see the difference. Oh my goodness, t cubed, come on. T cubed minus 0.5 t squared. Okay, so derivative is going to be 3t squared minus 3t. It's just the first derivative. And then acceleration is going to be the derivative of velocity. So that's going to be 6t minus 3. Versus, if I go to the other version, we'll have v of t is going to be 3t squared minus t. Yeah. Because if you have 1/2 times 2, that's just 1. A of t is just going to be 6t minus 1. And then both particles are moving right because the velocity is greater than 0. V of 2 was greater than 0. Whatever, like your reasoning, like pretty much every reasoning made sense. I don't think anyone missed that. 15. Okay. So.
Were each of these worth 2 points? 6.
Yes, that's why this page was 24 points. 24 points of Jell-O.
Oh.
Because when I was grading it, my head was like, yeah, Jell-O, yeah, we're doing well. No, it's probably, it's not bad at all. Okay. Okay.
Trying to salvage my career is all the points count.
Okay. So, derivative of tan inverse of x cubed. First off, what is the derivative of tan inverse of x? Do we know it? Okay, so I just said like x, but if I have something, if I'm taking tan inverse of a function, then I would have to multiply by the derivative of what's inside. So that was the thing we missed on this problem. Mostly we got the derivative correct. All right, so 1 over 1 plus.
Here on test B, the part B.
Do you have version B?
I figured it out.
Okay. 1 plus x cubed squared, and then I must multiply by the derivative of x cubed. So it's 3x squared. So this is going to be equal to 3x squared over 1 plus, ooh, tricky trick, x cubed to the second power. Is it 5 or 6? 6. X is 6. If you have, little note, x squared times x cubed, you would add the exponents. If you have x squared cubed, right, you have an exponent to an exponent, you multiply the exponents. Okay. Cool. So mostly did well. If questions over this one, yes.
Sorry, for the derivative part, can you go over that?
So the derivative of tan inverse is 1 over whatever's inside squared. So x cubed was inside, so I have to square it. And then I must multiply it by the derivative of the function that's inside. Okay, find the equation of the tangent line. So now we're looking for equation. Here's previous problem, we're looking for slope. Now we're looking for equation. So at x equals 1, well, we have an equation that literally tells us the slope at any point. So if I want the slope at 1, x equals 1, it's literally going to be 3 times 1 squared over 1 plus 1 to the 6th power. Really nice problem. You didn't even need a calculator for this. Trick play. Give your problem you didn't need a calculator for on the calculator section. 3 over 2. Cool. That's our slope. But you know y minus y1 equals m times x minus x1. Point slope form. That's all we really need. We have our slope. We know x is 1. The only issue is I don't know what y is, y1 to plug in, so I must find it. So if I want to know the value at 1, tan inverse of 1 cubed is just tan inverse of 1. Can you sharpen your pencil? No.
Huh? Oh,
Are
sorry.
you sharpening your pencil?
No, I
That was kind of you to wait. Normally people don't do that. You're in the middle of talking and there was a... Huh?
No.
I know. I was appreciating her for not being distracted. No. Okay, so kind of talked about this earlier. Tan inverse of 1. So I want to know which angle is tangent going to be 1. So automatically we know we are evaluating tan inverse. It's given to us. We're not solving for tan of theta equals 1. No, it's given to us. We have to evaluate. So that's when we use our restriction. Tan inverse restriction is negative pi over 2 to pi over 2. Well, tangent is positive, so we know it has to be in the first quadrant, because tangent would be negative in the fourth. So I know it's going to be an angle between 0 and 90 degrees, between 0 and pi over 2. So where is tangent equal to 1? Well, that's when sine equals cosine pi over 4. Yeah, it's got to be in radians.
I don't even know how like I couldn't even think that. Like if you said 10.
How many points did I take off for you?
I don't know, I'm just in general. You were fair. I also did it wrong.
Wow, that's really fair.
Yeah.
Okay. Well, no, I'm not taking more off. You see me? I see why I did this. You have an equation, you have a line.
Yeah.
So that's a point. And you realize this is 45 degrees, so you know the angle. That's what I mean.
Cool.
No, you're not allowed to do that.
Okay, this is my y value. So I have y minus pi over 4 equals my slope, 3 over 2 times x minus 1.
Tangent is cosine over sine? Or
Cosine is sine over cosine.
Wait, tangent is sine over cosine?
Sine over cosine is tangent. So when tangent equals 1, that means sine of the angle has to equal cosine of the angle. Sine and cosine are only the same at a 45-45. 90 triangle, aka 45 degrees, just pi over 4. Okay, we're almost done. And then we can go to like trick questions. Yay. Okay. questions over this one? Just read the problem. Am I looking for slope or am I wanting a line? I try to be clear. When I say find the line, if I find the slope, just find the slope. If I say find the equation of the line, you're looking for a line. Okay. Cool. Because if I see, there may be errors, but if you're plugging in the point slope form, and like you have the correct x in the place, and even if you got the slope equation wrong, but you plugged into it, and according to you, a carry through error, you put in the correct slope. Like, I want to give you as many points as possible. Please read the directions. A particle moves along an x-axis such that its position at any time is this: x of t equals sine inverse of 3t, where position is measured in meters and time in seconds. Find the velocity, aka derivative. So, the derivative of sine inverse, a little tricky. Just in general, of sine inverse, and I'll just say of x, 1 over square root 1 minus x squared. Don't forget, there's a square root on the bottom. Okay, so this is if we just have sine inverse of x, but here we have sine inverse of 3 times our variable. So then we have to multiply by the derivative of what's inside. So here, my x prime of t is going to be 1 over square root 1 minus, and this whole thing that's inside is squared. It's not just minus 3t squared, it's minus 3t, and 3t is being squared, not just the t, 3t. Okay. So, and then, we got to multiply by that derivative of 3t, which is 3. So it's 3 over root 1 minus 9t squared. So certain things we forgot. Maybe you forgot to put parentheses. Grouping symbols are your best friend. Oh my god, I've said it 10 more times since I told you that I would say it 10 times. Because it's the whole thing that's inside squared. It's not just squaring the t, you have to square the whole 3t right here. 3 squared is 9, 2 squared is 2 squared. Things we forgot. The root. Forgot to square the 3. Maybe we forgot to take the derivative inside. It's like lots of little things. Gotta remember to do. Yeah?
So for these types of problems, you're always going to do, it'll always be like times 3.
Times the derivative of what's inside. I want to get the most bang for my buck, right? So why ask 50 questions if I can test you on, all the same concepts in 40 questions? So this is testing you on like some chainy chain rule. So instead of just giving you a nice, just sine inverse of t, make sure we understand that, okay, cool, derivative of sine inverse, then the derivative of what the function that's inside. Find the velocity of the particle at 0 seconds. Okay, we just want velocity. Wait, this is velocity equation. So if I just plug in this number, I will find a number. Plug in 0. Three over root 1, which is just 3. Sorry, that's really small. Okay. Yes.
Because it's 0, like, okay, for 18, I didn't, it's square root of 3, so I got a different answer, but whatever. But because it's 0, I got the same answer for 19. Correct. Let's say it wasn't 0, and like
whatever you found in 18, if you plugged in 0 for time, and for 18,
would you still give us the points?
Yes, if you plugged into what you found on 18. Because what 19 is testing you is, do you understand the fact that I'm asking for velocity, aka the equation you just found? So you take the equation you just had, plug in the value I want, and then have the answer. That's a carry-through error. If I don't do carry-through errors, I think my test averages would be 30% lower. Well, because
there's some teachers who don't.
I know. But I'm trying to... it's not just the answer. I want to see, do you know how to do it? So I'm looking at the method. And that's one reason it takes me a while to grade, is because I'm looking okay, why did you do this? Does this make sense? Is this what we're supposed to do? Oh, you literally forgot a negative way up there and then you screwed yourself for the whole page? No, that's not fine. Yeah, that's my philosophy. So, you know, surprise, surprise, I care about you guys and like you, and I want you to succeed. Like, who would have thought, you know? Okay. It's a secret. Don't tell anyone. Okay. Cool. Right, so that's why you didn't, like, miss that one. Even if it was a different number, there's, like, other parts of the test where it's carried through. Okay, last one, intervals where it's continuous, a.k.a. find where it's not continuous, where it's discontinuous. So that means the bottom cannot equal 0. Oops, x squared minus 25 cannot equal 0. So if we solve for where the bottom equals 0, okay, well I could say this is x minus 5, x plus 5, because it's a difference of squares. You solve for the two places, it's equal to 0, and we know we have to cut these out, because this is where it makes our graph undefined. Why am I only looking at the bottom? Like, what about the top, right?
Because the top doesn't matter.
Right, the top doesn't matter. Cosine of x is continuous. It goes on forever, little wavy waves. It doesn't stop us at all. Versus if I had square root of x on top, then that would restrict our domain, but this one doesn't. So negative infinity, negative 5, union, negative 5 to 5, union, 5 to infinity. And you have to have the unions. That's part of the notation. Okay, and then I'd like to go over the bonus.
It's really simple.
No, it's not.
Once, it's just,
Simple for you.
it's like a light switch. Either you get it or you don't. First, f of negative 1 is 2. So I go negative 1 and I make a point at 2.
Yeah, I did that.
This is saying the slope. It's telling you what the slopes are. We have a point, f prime of x is the slope. So the slope is negative 2 all the way to 1. Okay, so I'm making a slope negative 2 all to 1. And then I got to continue with the slope all the way up here. Okay, this is a slope of negative 2. Then my slope is 1 from 1 to 4. So slope 1, 1, 1 right here. And it has to be continuous. Has to be continuous. Notice I have straight lines because my slope is exact.
Wait, how is it the slope? I thought that.
Yeah, I thought it was a
F prime of x. F prime is the derivative of my function. Derivative is slope.
I didn't even see that.
Yeah.
This is so difficult.
I put it
Okay,
straight.
and then from 4 to 6, it's a slope of negative 1. There. That's continuous, because look, I don't have holes in my points I'm changing. Interesting. So, do you understand the fact that slope is a derivative? Literally, to find the derivative is your slope.
Oh, yeah.
But
I've been giving you guys bonuses on all the tests, and you just don't get it.
But I don't
I put it
understand
in
where it's at.
Huh?
I put it in the calculator and it gave me this.
What do you mean?
I put all this stuff in.
Because it's a
and this is what
You
it
can't
gave
put
me.
it in derivative.
Yeah, you can't put it in derivative.
Okay.
Did you get it right?
No.
No. Because you didn't put it in the calculator, right? didn't
I don't
put it
understand what you do with f of negative 1 equals 2.
So, this means, so f of negative 1, this is my x value, is equal to 2, that's my y value. This is function notation. Function notation. It's telling you your x and y coordinate. I give you a coordinate, and then you just have to deal with the slopes from my piecewise.
Oh, wait, whoa.
Yeah, I gave you a point.
So that's essentially a point. So it's
Yeah, I literally gave you a point.
negative 1, comma 2. And then you
Yup.
put that in.
Which is what I did right here.
Okay.
Okay.
What do you do with that?
Well, I slope of negative 2, so I made this a slope of negative 2 right there. Yeah.
And then you like start.
Then, and then until 1, I made the slope negative 1. And then when I hit 1, I made the slope 1. Then when I hit 4, I make the slope negative 1. So if you've had me in class before, you know at least like you'll get a couple points of bonus on your final. You know me, what I do. Do what I do, cool. Yeah, we only have like 2 minutes left. But Tuesday, 8 a.m. is the final. I have bonus today.
Oh my god, it's Thursday, not Friday.
Yeah.
You're gonna be
Mr. Brian, are there?
So I have a final on Monday, 8, and then I'm leaving school at 1. So if you don't, I don't know.
What about
but like in between
When
between A and B.
when I like go to the bathroom and cry for a sec.
No, it's like an hour and a half break.
No, it's not.
Yeah, because you
I
have
have
to use extra
I have
time.
extended time from 8 to 11, and then my next final starts at 11:30.
So Brian,